Hey, we're going to look at rates of change and slope today. So rate of change is where we're going to compare the change in one quantity to change in another quantity. So a really common one would be distance and time. So we're going to look at an example using that. A car is going to travel at a constant speed, and we have a table down here that shows the relationship between how far we go and how long we travel. And our goal is to find the rate of change. So we're gonna compare that distance to the amount of time that has elapsed. So when we go to do this, we're always going to find our change in our y value first, and then divide that by our change in our x. So if I can pick any 2 points, you always have to find your rate of change between 2 points. And since our car is traveling at a constant speed, every single one of these pairs of points is going to have um, the same rate of change. So I went ahead and chose 3 and 4. So I found the difference between our y. So I did 240 minus 180. And then I divided that by the change in our time. So 4 minus 3. Okay, 240 minus 180 gives me 60. And obviously 4 minus 3 is 1. So we would have 60, and then our label is miles on top since we did distance, and our time is hours, so miles per hour. Rate of change coincides with slope of a line as well. So slope of a line of our graph is also a rate of change. We are going to look at our vertical change, which is our y, compared to our horizontal change, which is our x. So just like the previous example, we had y on top, x on the bottom. Slope is commonly referred to as rise over run. So this is really important for you to remember. If I ever ask you what are 2 common words used to describe slope, you'll want to remember rise over run. Okay. And then we're going to use that information, that vertical change over the horizontal change, to find the slope between 2 points on a graph. So here we have this graph and we're asked to find the slope. Well, we have to compare our vertical change compared to our horizontal change. I always go left to right. It makes the most sense. That's how we read. So I'm going to look, how do I get from this point to this point? Well, I know I have to figure out how much do I rise, or what's my vertical change. So I have to go up 1, and then my horizontal change is what we call the run. How many do I have to run left or right? So I go up 1, and then I go over 1, 2, 3. So my slope would be 1/3. Let's look at another example. Here we have 2 points again, and we're going to have to find the slope. So we go rise over run. Well, if we go left to right, I rise down 1, okay, which means that would be a -1. And then I run 1, 2. So I have my slope being a -1 over 2. I rose -1 and I ran 2. Just a couple key pieces of information. A positive slope will always rise when you look at it from left to right. A negative slope, however, will fall when you look at it left to right. So think about like walking up a hill would be positive slope, and if your graph looks like you're walking down a hill, that would be negative slope. We're going to look at 2 special types of lines to finish out our lesson. So we're going to have horizontal and vertical lines. Horizontal is obviously, think about the horizon, and vertical is up and down. So horizontal lines will always be the equation y equals some number. So C stands for constant. And talking about slope, horizontal lines will always have a slope of 0. So let's take a look at this example. Here I have graphed a horizontal line. We're going to go ahead and look at calculating that rise over run. Well, if I go from this point 1, 1 to 3, 1, I have not risen at all. So my rise would be 0, and my run is 2. And anytime you have 0 on the numerator, you have a slope of 0. Okay, 0 divided by anything is 0. So that is a justification or an example as to why our slope is always 0 for any horizontal line. And then this line, the equation is y equals 1 because it goes through 1 on our y-axis. So let's go ahead and look at a vertical line. Remember, vertical goes up and down. So our equation now is x equals a constant. And this time our slope is undefined, and let me show you why. So here's our graph. If we do our rise, we go from -1 to +1, so that's rising 2 units, 1, 2. But we have now run 0 spots, 0 places. Anytime you divide by 0, that's always an undefined expression. So whenever you have a 0 on the denominator, it will always be undefined. So our slope here is undefined. And then our equation, since it goes through x equals 3, our equation is x equals 3. All right, one more example together and then you'll have one on your own. So what's the equation and the slope of the following graphs? So here we have this graph. First of all, decide whether it's horizontal or vertical. And since it is vertical, we know that our slope is always undefined. Okay, so our slope is always undefined. And then we have to write our equation. Well, since it goes through the x-axis, we go over -2. Our equation is x equals -2. So I'd like you guys to find the slope and the equation of this bottom graph.